What does the future of verification look like? If you would have asked me this question when I first started in this business over 20 years ago, I probably wouldn't have told you artificial intelligence. But now, that's the absolute truth. As our IC designs continue to grow in complexity, the challenge is no longer just building functional IP. It's integrating that IP into increasingly sophisticated systems and identifying issues as early as possible. And we can't forget block integration and debug, which have become huge bottlenecks in our development cycles. The solution? AI, of course. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Priyank Jain from Siemens and I investigate the Calibre Vision AI platform and how this solution is helping design teams navigate the increasing complexity of full chip integration and speed up their debug workflows. We also explore the challenges of early full chip integration and the variety of benefits that Calibre Vision AI from Siemens can bring to your next design. And before we get started, don't forget to click that link. There you can find even more information about this topic from Siemens. Hi, Priyank. Thank you so much for joining me.
Hey, Amelia. It's a pleasure to talk to you. This is my first time at this show, and I'm very excited.
Excellent. I'm glad to have you. Okay, so before we get into the topic today, tell me, Priyank, what's new with Calibre?
So lots of exciting things are happening in Calibre land. As you know, Calibre has been golden sign-off for all top semiconductor companies. 98% of the top 50 companies sign off with Calibre. Calibre has been that unmatched leader, and we have been working very, very closely with our customers to bring even more exciting things in their hands. We have shown innovation leadership, introduced 7 new products in last 2 years. In addition to solving all the next node challenges, we are outpacing EDA growth. We have new customers every year. And then we are also dedicating a lot of bandwidth, a lot of investment to our R&D headcount. So there's a lot of R&D dedication. There is about 20% employee growth in last 2 years. And many of that predominantly has been to our R&D teams. And then specifically on the AI front, we have been investing in multiple areas, starting with user education, productivity. We have products for development and testing, job guidance optimization, and then last but not the least, we have results debug and fixing assistance. So these are the areas specifically for AI we have been investing heavily on. And let me walk you through some of the recent products that Calibre brought up. So last year at Siemens EDA level, we introduced this EDA AI system, Fuse, that brings generative and agentic capabilities across Siemens EDA products, whether it is Calibre, Questa, Solido, Aprisa, Expedition. We have Fuse powering AI workflows across all of these products. And one unique and distinctive thing about Fuse EDA AI system is that it's not closed. It's not just for the Siemens EDA products. Customers can leverage the APIs in Fuse system to build AI workflows across third-party products as well. And there are multiple usage modalities for this Fuse system. There are APIs, there's command line interface. We have been building in-tool GUI interface in Calibre integrations. And then there is web-based interface as well. The system is extremely powerful, supports all the latest and greatest LLM models. It has this multimodal data lake where customers can put their data. Siemens will have manuals examples in this data lake as well. And we're going to make it really data rich. And then it's extremely secure. Customers can deploy it either on prem machines or via cloud. So that's the base of what Siemens EDA has been building. We released this product last year, and now we have a lot of integrations, a lot of workflows in Calibre. I'll start with this AI documentation and assistance, which brings the power and knowledge of Siemens EDA documentation on customers' fingertips, right? So instead of going through manuals and application notes or contacting your applications team, customers can simply leverage the in-GUI interfaces to ask questions and get assistance. And then on the layout and the deck development side, we have LSG and SVRF copilots. Then we built and released this product called AI Run Advisor, which is targeted to help our customers optimize Calibre runs even better. Recently, we added Check Assistant and Fix Hints in Calibre interfaces. And last but not the least, we have Calibre Vision AI, which is powering faster full chip DRC debug with the AI and ML algorithms.
Priyank, this is very impressive. So let's go back to Vision AI. I want to start with what is early chip integration? And Priyank, why is that important?
So before we dive into what is full chip integration, I think it's important to understand what is a chip. So I have this example of NVIDIA GPU. NVIDIA has been in discussions for several years now, gaining a lot of popularity. And as you can see, this chip, it's not one single piece of building of transistors, but it's in fact a combination of multiple blocks and partitions coming together and stitching to create this full chip, right? So there could be tens of blocks to hundreds of blocks that forms a full chip. And there are hundreds of block designers, partition owners working on block building, and there are dedicated full chip teams, we call them SOCs. So the SOC teams, they are taking these blocks from the block engineers, and their job is to stitch them together to form a single chip. Now, if we look at this whole process, the whole process of building a chip starts from RTL. And there are hundreds of block engineers working day and night to build blocks. And there are these PV cycles, shorter PV cycles in between. And then the full chip integration works parallelly to the block building to assemble a full chip. And they are also working around the clock. Collectively, the goal is to get a cleaner tape out on time. Now, somebody might imagine that the full chip integration would happen once all my blocks are super clean, they have completed. Then only I'll start assembling them, right? That is not correct. In today's world, where there's a lot of pressure, time pressure from the market, the full chip integration starts much early in the flow. And what that means, simply imagine your blocks are not clean, they're not complete, and the SOC owner started to put these blocks together. What they will see is an array of problems, right? Because the blocks are not clean. They're just starting to put these multiple blocks together, and there are hundreds of blocks. And what are some of the common problems? Imagine I have two blocks. I'm going to place them close to each other. Both of these blocks have pins, and there is a pin axis issue or mismatch between these two blocks. Or somebody might have placed these two blocks too close to each other or too far from each other, or they might be overlapping with each other. So these are some of the common challenges the SOC owners see when they start to assemble a full chip. And what these problems, what they lead to, essentially when somebody runs DRC on this full chip, it generates billions of errors. I mean, tens of millions is so common that nobody talks about that. I mean, we are really talking about tens of billions of errors now. And it is just overwhelming for our designers. I mean, to see this kind of scale, they don't know where to start. They don't know how to control this. They don't know how to debug this, how to fix these problems. And often what SOC engineers, they will do is limit the errors per check so as to control the volume here. And what happens when they limit, for example, 1,000 error or 10,000 errors per check, they get very limited information. They miss that across the die view. They miss systematic patterns, and it takes multiple iterations, more iterations for the SOC engineers to identify the gross failures.
Wow. So, Priyank, there are hundreds of designers working around the clock. So, can you explain what are some of the most critical and common challenges in full chip integration?
Yeah. Let's say a team of engineers, SOCs, block engineers working on taping out this chip. And let's say if they get into these billions of errors, what is the scenario in that team, right? Where do I even start? I mean, there are thousands of checks, billions of errors. Which checks to look first? Which checks to start debug first? Which errors do I segment? How do I form check relations? So these are some of the common questions that the SOC engineers ask when they start on a full chip debug. And then if that SOC engineer is expert enough, spend 20, 25 years doing this, he or she might have some clues, some ideas of, what checks, what areas, what cells they want to start looking at first. But then there are newer engineers joining our workforce. They won't even be able to load this data. I mean, forget about starting or debugging this data. I mean, we often hear this, like I can't even load and navigate through these billions of errors. So it takes a lot of iterations because they have to then cut this big database into smaller segments and do the debug check by check or a set of checks. And then there is this manager or somebody sitting at top and always pressuring, have you found the problems yet? Because the clock's ticking. The tape out deadline is a pretty serious and a hard deadline. And then the block engineer is waiting because he wants the instructions or he wants the guidance from the top level, because the top levels guy is gonna tell the block level team, like, these are the changes you need to make in your design to make it compatible or to reduce the errors at the interfaces. So there's multiple engineers, multiple people working in conjunction to each other, and just going through this massive data sets pose a huge challenge to all of them.
All right. So, Priyank, can you walk me through the details of Calibre Vision AI?
Absolutely. And that's the solution I have here, right, for our audience. So Calibre Vision AI is a revolutionary AI guided analysis engine that stimulates early chip integration. And the end goal is to compress cycle time. So many years back, when we started talking to our customers, one thing that came up again and again is the current flows, the traditional tools that we have or the customers have are not sufficient to handle the scale of data, and they need something better. And additionally, in the era of AI, there was a lot of expectations from our customers that, our tools become intelligent enough, they become smarter so that they start helping the designers do faster debug and get to the problems faster. That's where we started developing Vision AI. So we launched this product last year. It has been gaining a lot of attention with our top hyperscalers and blue chip customers. So coming back to Calibre Vision AI, it has three essential legs, as we say that, right? So first is fast full chip analysis. So we built Calibre Vision AI ground up with the newer technologies. And because of that, we were able to add the high capacity engine that would load the data super fast and offers lightning fast navigation through billions of errors. Once the data is loaded, Vision AI looks at all of these thousands of checks and billions of data errors and creates intelligent clusters and prioritize these clusters for our designers so that they get a clear starting point. And instead of doing a check by check analysis, they do group by group analysis. And then there is user collaboration. So Vision AI streamlines the data distribution across various teams. So I'll have more details in next couple of slides. But in summary, all of these three legs working together to shift left the chip integration. And the goal for us is to help designers identify and resolve issues early in the design flow and get to the tape out clean designs faster. On to some of the details, right? So this is the UI, the user interface of Calibre Vision AI. You have the layout viewer sandwiched with violations and a heat map that reveals the concentration of these violations. And that's the heart of this tool, because debug is a highly visual process. So we were really mindful in creating this fast visualization engine at the core of this product. And then to support the visualization, we have the ML-based check groups on the left. There's a lot of check help in Vision AI, then your usual layer cells and check panel helping with the debug. So this is the user interface of Calibre Vision AI. And there's a lot of control, a lot of flexibility. This is a multi-threaded engine, so it's extremely powerful and extremely fast. Now, let's get into the capabilities. So we talked about fast full chip analysis, just loading the data super fast, analyzing millions of errors. It offers 5 times higher productivity than some of the traditional debug flows. So very, very powerful. And then we also talked about intelligent debug, clustering checks and forming check groups. We call them signals. So forming these signals so that customers don't have to go through check by check. Instead, they get clear starting points, these prioritized check groups, and improve the time to resolution. And some common problems that Vision AI helps identify is, for example, bad VRA, there's block of misalignment, a lot of cell abutment happens in the early stages, and then there is a lot of overlap, fill with clock cells, one block to another block. These are some of the common problems that Vision AI quickly identifies in form of signals and helps the debug process. And then for the cross-user debug, we have a thing called bookmark, where designers can save the exact state of the UI, and then let's say they send that bookmark file to another engineer, a peer in their group. When that person opens the bookmark file, they'll get exactly the same view of the tool that the bookmark was saved in. So handing over the analysis gets much easier. And then we have a feature called results distribution that enables seamless distribution of results from top level to block engineers. And engineers can export results of subblocks or cells as OSS and ASCII as well. So there's a lot of cross-user collaboration capabilities in Calibre Vision AI. In summary, you get higher productivity, faster debug, you have intelligent clusters to give you starting points, and then capabilities to kind of work together on this full chip.
This tool seems very powerful. So, can you explain what some of the key applications would be?
Yeah, and that's where I think I'll take a little bit of time to go through some of the common use models. So I won't be able to going through every single use model Vision AI offers, but some most popular ones. And I'll start with this faster check cell analysis, because check cell analysis is something that is extremely common, extremely popular today among all the designers, SoC owners. And I have the traditional method on the left, and I have the Vision AI debug method on the right. So on the traditional method, what happens? So the SoC owners, they're using a layout viewer like Calibre Design Rev or maybe another layout viewer to load the layout data. And then they use a results viewer, could be Calibre RVE or some other results viewer, to load the DRC results coming from Calibre, which is your ASCII-based database. And the connection between the results viewer and the layout viewer is via socket, the serial connection. So now let's say if I have a check with 100,000 errors, I want to highlight those 100,000 errors from my results viewer to the layout viewer to understand what is the extent of those errors in my chip. Just sending that data through the socket could take minutes. Now take that to the scale of millions and billions of errors. So the whole debug process becomes extremely sluggish. Now, with Vision AI, we have layout, results, and other capabilities like bookmarks, all of these loaded onto the same server. And because all of this is loaded to the same server, the navigation and visualization becomes extremely fast. So the same check cell analysis that customers do using traditional methods becomes 5 times, 10 times faster. And I have some example from some real data here. So on the left in the bottom chart, I have the blue bar, which is representing the traditional flow, and I have the green bars, which is representing the Vision AI flow. And as you can see, the results database size itself is 38 times smaller compared to the traditional method, because the traditional methods use ASCII format for the results database, and Vision AI uses OSS database format, which is much better. There are a lot of compression techniques that we are using to compress this data by 30, 40x. And then when you load that data onto these different tools, you get 10 times faster loading performance. So just by loading this data, it gives you this enormous amount of saving. And then once the data is loaded, you want to highlight and navigate and do your textile analysis. So doing all of that in Vision AI is extremely fast because all of this data is living into the same cockpit, into the same server. So let's say if you want to highlight 10 million errors from your result viewer to a layout viewer, it takes 7 minutes. You click a highlight button and then you're just waiting for 7 minutes for that highlight to happen. On the other hand, for Vision AI is near instantaneous. This is extremely, extremely powerful and increase productivity by multiple X due to the same check cell analysis. Now, so that's the base, right? So customers are doing check cell analysis. We understood what Vision AI is doing to aid that check cell analysis and increasing the productivity there. Now, coming back to this intelligence part of it, right? The expectations from our customers is for our Calibre tools to become intelligent and smarter, right? That's where the ML-based check groups comes handy. The traditional method on the left explains what designers do today. So let's say they have thousands of DRC checks, millions and billions of errors. So first of all, they will need the super engineers, the SoC guys who spent 20, 25 years working on the same kind of chips. So they will have some idea. They'll be forming some mental check groups and trying to find the starting points. And often they perform repetitive analysis because the same systematic failure could cause multiple checks to fail. Let's say if they looked at one check first, they identified the root cause, then they looked at another check. Oh, it's the same problem. They looked at the third check. It's the same problem, right? So they were doing a lot of repetitive analysis. Now, on the Vision AI side, what the tool does, it uses ML algorithms to analyze these checks and creates signals, aka check groups, based on a common failure pattern or based on a common root cause. So, for example, let's say if there is a bad via array in my design, and there are 3 or 4 checks failing because of that bad via array, for example, via enclosure, spacing, density, these checks could fail together. Now, the root cause is your via array. You need to go and improve that. So, with Vision AI, you are doing group by group analysis. You're looking at multiple checks together and getting to that root cause faster. This image is just to illustrate the concept here, right? So, for example, let's say if I have checks A, B, C, D, E, F, G, H, and I, the top 4 checks A, B, C, D, they're failing because of a block overlap, and G, H, and I checks are failing because of the VS spacing and enclosure issue. The idea is we group these checks together because they're failing from the same problem, and we attack this group once we identify the root cause, and we fix that root cause and we move on to the next problem. That's the idea of ML-based check groups. I wouldn't say this is entirely new concept because the expert SoC engineers, they have been doing this a lot, but they have to rely on their own expertise and own judgment to form these mental groups. By using ML algorithms, we are just enabling that capability in the tool so that even the new designers can start leverage the ML based algorithms and they don't have to go through all that work.
So, Priyank, how is Vision AI able to highlight 100 million errors in a few seconds?
The reason we are able to do that is because results, the layout, all of that is loaded onto the same server. And now, because it is already loaded, there is no communication happening. The only thing we need to do is, for example, let's say if a customer selected or user selected a check that has 100 million errors, as you mentioned, we just have to show that 100 million errors. We just have to change the GUI view, and that could happen in a fraction of a minute. Like there's no data transfer. And because there is no data transfer, because there is no communication happening through socket, it is extremely fast. And that's how we're able to do that in such a small time.
How is Vision AI grouping these violations and what's happening under the hood?
That's where I think much of it is kind of the secret sauce for Calibre, but at a high level, explain what we are doing. So we're using artificial intelligence and ML algorithms to look at multiple areas, right? This is kind of a multi-axis thing. So we look at the spatial patterns, we look at the locations of these patterns, we understand the check relations, and based on that, we create these clusters.
How does this platform help with documentation?
I have a slide that talks about that. But before I get to that, I want to quickly take a couple minutes on explaining this collaboration, right? We talked about cross-user collaboration between the top level and the block level guys. So this image is pretty busy, and I'll spend a minute to talk about this very high level, right? So here we have the top level guys who are looking at results, and they're mostly interested in the results at the interfaces. And now they identified some changes that block owners needs to make. So what they do is, in the traditional workflow, they would run a lengthy script to push these results from top level to block level. Then they create these detailed notes, and they have to do a lot of hand holding for the block owners to make those changes in the blocks. Whereas in Vision AI, they can leverage the results distribution capability. They create bookmarks, add notes, push results, and export the data, all of that as a package with few click of buttons. And the block owners, what they get this necessary context for the block designers. They get all the pushed interface results for all block instances, and they can step through these instances to understand what changes they have to make. With that, they can understand what's happening inside my block, what's happening at the interfaces, and what's happening at the outside of my block extent. This is one of the capabilities that a lot of customers have been waiting for. And now on to your question, right? How does Calibre Vision AI help with documentation? So we talked about the EDA AI system, a Fuse system that's powering AI, generative and agentic AI workflows across Siemens EDA tools. So Calibre Vision AI also has deep integration with this system. And what does it bring? It brings documentation assistance. That's one very important thing. Let's say if I have a question, I want to do some task. What I do today is I would go and check in the user manuals and try to find how would I do that task. Whereas with this large language models, customers can simply ask a question in natural language from the GUI interface in Vision AI, and Fuse will help populate this answer. It will go through all the manuals, select the appropriate answer, and quickly present that to our customers. And not just that, so documentation is just the start, just the tip of the iceberg. The second big capability that the system enables in Vision AI is the summarization. So for example, let's say if you're looking at some data, certain checks, certain signals, you can ask LLM to help you assist in the debug process, summarize data for me, or find the root cause for me. Let me know what is the next step on this. So this is summarization and then kind of reasoning LLM brings to the table. And then on not just summarization, customers can in fact perform actions using natural language queries. So for example, look at these checks, filter out checks based on error count, zoom into a specific area of the design, or look at a certain cell, create bookmark, find root cause. All of these actions can be described in simple natural language query, and Vision AI will perform that. That would be the basis of building the agentic flows. So we will have MCPs for Vision AI, MCP server. And what that would enable is the agentic DRC debug workflows via any IDE, whether it is VS Code, Cloud Desktop, or Cursor, or Copilot. I'll go into the demo that briefly shows all of these aspects: documentation assistance, summarization, and actions. So we looked at different capabilities, and together with this agentic AI workflow, Vision AI is an extremely helpful tool that can help new designers perform expert debug with a lot of ease, and they can generate higher productivity.
Priyank, summarize what we've covered today. What exactly does Calibre Vision AI offer for chip designers?
So, in summary, I think the first thing I want to highlight here is the 5x faster full chip debug, right? With faster loading, lightning fast navigation, check based analysis, then signal based analysis, then cross user collaboration. So, all of these capabilities kind of coming together and providing that 5x productivity boost. And not just that, right? With this results distribution we have seen, Vision AI brings both the block owners, chip owners, partition owners very close to each other. And it helps build trust among various organizations, among various teams. And then the fuse powering generative and agentic workflows, it opens the door for agentic debug, where Calibre builds the infrastructure, it builds some agentic flows, but then customer takes it to the next level. They enable a lot more agentic flows using the infrastructure we have built here. And then last year, a couple of customers like AMD, Samsung, and OnSemi, they took the stage and they talked about their experiences and how they're leveraging Calibre Vision AI to accelerate full chip DRC analysis. And I would encourage the audience here to check out the Siemens EDA website for a user-to-user library, and you'll be able to find the presentations from these customers there.
Fantastic. Well, Priyank, I think that's all I have time for today. Thank you so much for joining me.
Thank you so much, Amelia. It was very, very excited to talk to you, and it was a pleasure to be on this show.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Siemens. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.